Okay. Uh-oh. I'm going to talk about Unit 16, and this is about casting concrete slabs on grade. So I'm going to, or the unit's entitled Poured in Place Concrete Foundations, but this goes along. I know y'all have taken architecture technology, but these are a few slides from my lecture in that class on concrete slabs on grade, which I thought pertained to this. But before I get into that, I did send an announcement on Canvas about where we should be at, and just to reiterate that, next week there's technically not class. If you're not participating, then you should be up here finishing your work if you're not participating in the charrette. And by Tuesday, November 5th, your goal should be to have all your assignments through this unit, Unit 16, complete. And at that point, anything before Unit 13 will have an automatic 10-point deduction turned in after that date. Does that make sense? Okay. And then the schedule is that we will continue on through Unit 23, which will cover around Thursday, November 21st. Then we'll have our exam, our third exam. And then I'll give you your final project, which will be due December 10th. So my goal is that you won't be working on these assignments while you're working on the final project, or else you're lost. So anyway, so now Unit 16 is about poured in place concrete foundations. That involves building the forms in place at the job site, placing steel reinforcing bars onto the forms, and pouring concrete onto the forms around the reinforcing bars. And that's what these slides depict. This is just a detail showing a concrete slab on grade. The top one is. The bottom one is obviously suspended slab. But you can see that the earth is depicted by the crosshatch. Then you've got a layer of gravel. Then you've got your rebar. And that's what you'll be drawing, and as well as these concrete beams in your assignment. So I won't go through all of this, but that's just the preparation of the site. Then you've got the gravel. You can see there that was shown back up here. That's this gravel. That allows for drainage. Then in this particular thing, they're doing the driveway. They have their edge forms, which they built on site. Then they've got their rebar specified by the engineer. And then they're going to pour the concrete on top of that. That's just a detail showing the slab edges. You have to have joints so that the concrete doesn't rub against each other where you're having different pours. Also, it allows for expansion and contraction and keeping the slab from getting cracked. This is a picture. They've already got the moisture barrier down, and they're about to lay their rebar on top of that. Here's a picture of the rebar up close. You'll be drawing rebar in your detail. There's another picture of a welded wire fabric sitting on chairs. These are sometimes called chairs. That holds it up into the middle of the slab so that it's not falling to the bottom. Here they're actually pouring the concrete. You can see the rebar down here. There's an up-close view. Then they finish it off, striking it or screeding it, making it smooth, and then eliminating any pockets of air. Then they float it, and they finish it. And they got to finish the corners, obviously, so it won't chip and crack. I'm not really reading all this to you because I just wanted you to be able to see pictures of the rebar and how they finish it. But I did want you to watch this. It's a little, hopefully it'll work.
Good day everyone, here we are back at Redcliffe in a follow-up to our pre-slab videos I did recently. This flat here, this video here shows the plastic and mesh stage when doing a concrete slab for a house. As you can see over there with the power conduit into the floor ready for the power to be connected to the house later. This area just here is the garage area which has no rebate on it. You'll see just down here that there's a section of timber, I suppose, just clipped onto these brackets clipped onto the boxing. They're actually the rebate that forms up for the brickwork to go into. You'll see through as I just walk through the mesh that they put down, the little bar chairs they call them, hold the mesh up. That gives the correct clearance.
So I just thought that was a good little look at, let me see if I can get out of this. Hello? How does that reduce? Okay. There. All right. So now if you look at your book, Unit 16, of course you can read all this. There's what we're concerned with in this unit is the engineering drawings for poured in place concrete. There's two types. There's the engineering drawings and there's the placing drawings. The engineering drawings are what the engineer draws, of course, and the placing drawings are more detailed, kind of like shop drawings is what I would call them, but the book calls them placing drawings. And you're going to be asked to draw one of each of those. It tells you the differences. Engineering drawings just give the overall size of the structure being drawn, the size of this. You have to worry about the the placing of the beams and stuff like that. It tells you appropriate scales to use. Plan views are usually 1/8 or 1/4. Elevations are 1/8, 3/8, or 1/2. And sections are larger scales. It talks about symbols and abbreviations, which we've gone over before, and that eases the drawing time and consolidates information. Then it has the mark numbering system, which of course can be changed in each different office, but generally most systems use numbers to designate the floor levels and to designate the structural components, and the numbers to identify specific components, like beam numbers 1, 2, 3, and 4. And that'll be important on your schedule. You use letter designations for the different elements of the poured concrete. B is beams, C is columns, and so forth. F is footings. It lists those on page 237. And then it talks about schedules, and just like our other chapters where we did schedules, you have to list everything out so that everything can be accounted for and you have the right amount of stuff. So if you're preparing an engineering drawing, you need to have all the information relating to the size and arrangement of the concrete members, and the size, positioning, and arrangement of the reinforcing bars in the members must be provided. And you get this from sketches and drawing notes, etc. You can have some typical details, but you need to note where those apply. And if you look on page 240 and 241, you have an example of engineering drawing and a placing drawing. And you're going to be drawing not these, but a similar thing, so you need to study these examples. The engineering drawing is a lot more general. It doesn't have the schedule on it. It doesn't have as many notes and indications. It just has an overall plan, overall dimensions, and typical section size. The placing drawing, which is shown below on page 241, it shows exactly where each bar is and the spacing required. It tells the size of the bar and then where to look, gives it the marking number so you can look up in the schedule and see what all's there and how it's configured. So that it just has a lot more detailed information. So you need to study those, and then for your activities, assignment 14, if you're looking on the screen here, for unit 16, page 243, number 2 and 3. On our typical 11 by 17 sheet, you're going to do activity 2 and 3. Using the information on the next page, on page 244, you're going to use that information to draw an engineering drawing for number 2, and then a placement drawing using that same information for number 3. So you can decipher the difference between the two. So, and like I said, I would like for everyone to be through this assignment when we come back to class November 5th, so that, you know, we can move on and y'all can be ready to attack your final project when we get there and not be so far behind. But that's, y'all have any questions, the two of you that are here? Okay. All right, so that's it.